Hello viewers, in today's class we are going to discuss one important problem from Rolle's theorem, right? And here we have a very interesting and important problem in which we have to verify Rolle's theorem for this function f of x, which is equal to x times x plus 3 times e raised to minus x over 2, right? And the interval is given as the closed interval from minus 3 to 0, right? So here we have to verify Rolle's theorem for this function in this interval, right? So let us first quickly see the statement of Rolle's theorem for a quick revision, right? Now see, Rolle's theorem says that if we have a function, say y is equal to f of x, which is defined in some interval, say a comma b, right? And if this function is continuous in the interval, closed interval a comma b, and this function is differentiable in the open interval a comma b, and the third condition is f of a is equal to f of b, and if these three conditions are satisfied by any function y is equal to f of x in the closed interval a comma b, then there must exist a point c which belongs to the interval a comma b, right? So here this interval is open interval from both the sides, so there must exist some point c which belongs to this interval a comma b, such that the derivative of this function at this point is equal to 0, right? So the derivative of this function must vanish at this point, that is x is equal to c, right? So the slope of the tangent at this point x is equal to c should be equal to 0, or the tangent must be parallel to x-axis, right? So now we'll see this function, whether this function it satisfies these conditions, and moreover if there exists a point c belonging to this interval minus 3 comma 0 such that f prime of c is equal to 0, right? So let us verify these conditions for this function, right? So here we can see that this function f of x can be written as x square plus 3x times e raised to minus x over 2, right? So here we can express this function as a product of two functions. So x square plus 3x is a polynomial function, right? And e raised to minus x over 2 is the exponential function. And we know that the polynomial function is continuous in its domain, right? And the exponential function is also continuous in its domain, right? And moreover, the domain of x square plus 3x is the set of all real numbers, right? And similarly for this exponential function, the domain is the set of all real numbers, right? So we know that if we have the product of two continuous functions, then the resulting function is also continuous. So we have seen that this function f of x is continuous in the interval minus 3 comma 0, right? Okay, now let us differentiate this function f of x with respect to x, right? So f prime of x can be written as d by dx of x square plus 3x times e raised to minus x over 2. Now here we have the product of two functions. So what we will do, we'll first take this function x square plus 3x, and then we find the derivative of e raised to minus x over 2, and then we take this function e raised to minus x over 2, and we find the derivative of x square plus 3x, right? So here we have used the product rule, that is d by dx of u times v, where u and v are both functions of x. So we have u, then we have dv over dx, then we have v du over dx, right? Now here we have x square plus 3x. The derivative of e raised to minus x over 2 is e raised to minus x over 2, and then by chain rule the derivative of minus x over 2 is minus half, because the derivative of x is 1, right? So we know that the derivative of the exponential function is the exponential function itself, right? And here we have e raised to minus x over 2, and now the derivative of x square is 2x, and the derivative of 3x is 3, right? So now we can write this expression by taking e raised to minus x over 2 common, right? So we have inside the bracket x square plus 3x over minus 2, and here we have 2x plus 3, right? So now let us further simplify f prime of x, that is equal to e raised to minus x over 2, and we can write x square plus 3x, and here we can take the LCM. So we have minus 4x minus 6 divided by minus 2. So now we can have e raised to minus x over 2 and x square minus x minus 6 over minus 2. This is f prime of x, right? So now the derivative of this function f of x is given by this expression, right? And we can see that the derivative, it exists, that is the derivative of f of x, it exists for all values of x belonging to the open interval minus 3 comma 0, right? So this derivative exists in this interval, right? Now f prime of x can be written as x square minus x minus 6 over minus 2 times e raised to minus x over 2, right? And now let us take the third condition, right? Now see, f of a should be equal to f of b. Now here a is minus 3 and b is 0, right? So let us find f of a. So this is f of minus 3. So f of minus 3 can be obtained by substituting x is equal to minus 3 in this expression. So we have minus 3 square is 9, and here when we take x is equal to minus 3, this is minus 9, right? And we have here e raised to 3 over 2 by taking x is equal to minus 3. Now 9 minus 9 is 0, so this is 0 times e raised to 3 by 2, that is 0, right? And f of b is f of 0. Now see, when we take 0 in this function, this term is 0 and this term is also 0. So the entire terms becomes 0. So we see that f of minus 3 is equal to f of 0, right? It implies that the value of the function at these two endpoints are equal. So now we see that this function, it satisfies all the three conditions of Rolle's theorem, right? So this function is continuous in this interval, then this function is differentiable in this interval, and f of a is equal to f of b, right? So now there must exist some point x is equal to c belonging to the interval minus 3 comma 0, such that f prime of c is equal to 0, right? Now if we take x is equal to c, in this expression we'll get c square minus c minus 6 over minus 2 times e raised to minus c over 2 is equal to 0, right? So the derivative must become 0 in Rolle's theorem, right? Now we can multiply here this term with 0, so we'll get a quadratic equation in C, right? So this is a quadratic equation in C, and we can easily solve this equation by splitting the middle term. So we have c square minus 3c plus 2c minus 6 is equal to 0. So minus 3 and plus 2 are the two factors here, right? Now taking common here, we have c minus 3, then we have 2 and c minus 3 is equal to 0. So we have now c minus 3 and c plus 2 is equal to 0. So now we have the product of two linear factors, right? So when we take c minus 3 is equal to 0, we get c is equal to 3. And when we take c plus 2 is equal to 0, we get c is equal to minus 2, right? So we have obtained here two values of c. One is minus 2 and other is 3, right? And if we observe these two um, values of c, then we can see that only this point, that is c is equal to minus 2, it belongs to this interval, that is minus 3 comma 0, right? So out of these two values, only minus 2, it belongs to this open interval minus 3 comma 0, right? So Rolle's theorem is verified by this function in this interval, that is closed interval minus 3 comma 0, right? And this point c is equal to 3, it does not belong to this interval. So viewers, this is how we can solve the problems related to verifying of Rolle's theorem for particular functions in some given interval.